Hi, I'm Teacher In. We continue our learning of this chapter. This is number 3 PPT document. From now on, we will use the energy equation frequently. I hope you more and more like it. It's so useful in analysis of flow problem. I almost forgot one thing in energy equation. Please forget absolute pressure in flow problems. We only use gauge pressure in our calculations because all flows that we discuss here are surrounded by the air, and atmospheric pressure doesn't contribute to our flow. First, let us learn the working principle of a velocity instrument. Pitot tube. It was invented by a French physicist, Henri Pitot. Look at picture. Here are some streamlines and static tube 1 and total head tube 2. Now, ignoring the friction, we write Bernoulli's equation for streamline segment AB. Point B is on the end of tube 2. So velocity UB is 0, and in tube 2, the piezometric head is equal everywhere, including at the end point B. It's just the water top in the tube. Now look at tube 1. Its bottom end and point A are on the same GVF section. So they have the same piezometric head, which is the water top in tube 1. Hence, the piezometric head difference of A and B is h. Then we find UA. If friction and other influences are counted in, we should add a factor C to correct the ideal result. This factor will be calibrated in laboratory by the manufacturers. Sometimes, if the velocity is very large, mercury U-tube manometer should or have to be used to get the piezometric head. Thus, we should give a value of 12.6 to convert the mercury column HM to a water height. These are some pitot tube applications in reality. Next is a device to measure discharge rate. This is a Venturi tube designed by an Italian physicist, Giovanni Battista Venturi. Venturi tube includes a convergent entrance, a cylindrical throat, and a divergent outlet. Fluid passing through the tube speeds up as it enters the throat, and the pressure drops. We will use energy equation to explain its cleverness. Now write the energy equation between entrance section and throat section. It's section 1 on the top. Pay attention, both sections are GVF section. Note there's a U-shaped differential manometer with its two ends connecting the two sections respectively. You have learned the differential manometer in statics chapter. Differential manometer is a lovely device to obtain directly piezometric head difference between its two ends. Here are 3 points for it. Number 1, it gives piezometric head difference, not pressure difference, not pressure itself. Number 2, it measures directly. Yes, just read the value of h. Number 3, it's the difference between its two ends. If fluid of H is different from the measured fluid, we need a conversion, as I marked with red in the page. Well, the sizes of the tube are given by the producer. Now combine the result from equation 1 and the continuity equation 2 on the bottom. We can solve the velocity v1 or v2, then find the flow rate q. Finally, we have such calculated expressions. To consider frictions, discharge coefficient μ is introduced. Geometric factor k is determined completely by geometry of the tube. Now let's look at typical flow as an example. You can pause to read the question. The pipe size is given. Then the first thing we think about should always be continuity equation because it contains the least number of unknowns, just Q, V, and A. So the next thing is to find the velocity in pipe. Try energy equation. I believe you understand the process I wrote to you here, but can you be able to answer the following questions? Number 1. Why do we select the datum location like this? Actually, you can choose any place as long as it is horizontal. It will not affect our solution completely. However, you will find the one crossing through the outlet center is the best for our calculation with z2 is equal to 0. Number 2. Why select free surface, which is marked by a triangle and a short bar below it, as our upstream section 1-1? We know on surface open to the air, the pressure is 0, so P1 is 0. If you select other places, you will run into pressure that you don't know, and usually free surface is a GVF section. Please keep in your mind that the free surface is good to find points, pressure, and level. In fact, it is just a huge natural piezometric tube. Number 3. Why select outlet 2-2 as our downstream section? Why not the inlet of the pipe? Section 2-2 is a GVF section and open to the air, so pressure here is also 0. It is the P2 is equal to 0. If we choose the pipe inlet, it isn't a GVF section due to streamline convergence, and the pressure is still unknown. Number 4. Anything else? Okay. Ask me on class if you have. First, please pause to read the question. Now my question is, why put upstream section 1 still on the free surface? Is it really a cross-section? In fact, for a big water body, if the flow speed inlet is very small, we can ignore it. In such cases, only potential energy in it contributes to the flow. Although here is a river, but the river speed is normal to the pipe, so it doesn't work on the pipe flow. Only piezometric head in upstream gives energy to the pipe flow. Therefore, we choose point on top surface as our calculation point. So does the downstream section. You can see here the level difference between the two water bodies are entirely used to overcome the resistance. It is be equal to the head loss. So, most of the time, we see water flow has a drawdown where the potential energy transformed to head loss if velocity didn't change a lot. In this example, we see the water going up. What happened? Because of negative pressure or vacuum, it plays a role of suction. Here from the top equation, the negative pressure on the left cannot turn to a positive pressure on the right by itself, except extra energy from outside is given to the flow. That is HP from the pump, which is called lift head of pump. I must say, you are supposed to study these examples by yourself before listen to my instructions. Did you do it? Okay. From this siphon example, you can see as long as the upstream level is higher than the downstream level, the flow in between can happen. The negative pressure at a higher place are crucial to the flow. So if there's some air in the siphon too, it cannot work. That's why we must fill the tube with water before it works. Well, you are supposed to study this page yourself. When you finish the reading, you will see here again the benefit when you select the points on free surface. Please take a good look. Do you fully understand what was said before? If you don't, work it again, or give your questions to me on class. If you do, please ready for the next.